In this challenge, you have to do 5 tasks, and all these 5 tasks are similar. So once I show you the procedure for first one, so just with minor changes, you can solve other tasks also. Let us pick up the first one. The first one is displaying digits of a number. You have to display digits of a number. What does it mean? See, suppose if a number is given like 257, then you have to print all these digits 2, 5 and 7. All 3 digits you have to print. That's what the task is, very simple. But it is a single number, how I can take out the digits from this one. So I will show you how to take out the digits. But one thing, remember, we cannot take out digits from the first digit onwards. We can take out from the last digit onwards. Let us see how we can do it. I will write down a number here. This is a number, okay? 257. Follow the steps. How I can take out the last digit of this one? If I divide this number by 10, then 7 will be a remainder. It will get divided by 25 times and the remainder will be 7. So if I find out remainder by using mod 10, then I get a digit 7. Oh, I can get the digit of a number, but I can get only last digit. Let us call this as a remainder. Now next, how to get the next number? Now you cannot take out 5 unless you remove 7 from this one. So how do you remove 7 from this one? We will divide the number, that is 257, divided by 10. So we will divide it. So we get the number 25. So we will divide the number by 10. This 25, we will take it again and do the same step. What to do? Find out the remainder. 25 mod 10 is what? 5. Then divide 25 by 10. 25 by 10, you get 2. So I will write down 25 divided by 10 gives 2. Take this 2 here. Then 2 mod 10. 2 mod 10. See, when a number cannot be divided, then directly you get the remainder. That is 2. Then 2 divided by 10, this will be 0 in terms of integer division. If you are taking float, then it will be 0.2. But no, we want integer division, so this becomes 0. And then when the number became 0, you should stop. So I have shown you the steps. Now you have to frame it using a loop. How to do? I will give you little idea and you try to write down the code. Okay? I will give you time for writing the code. See, you have to take a number, 257. Then find out mod. Then divide the number by 10. So you get a new number and call that as a number again. So number n assign n divided by 10. R assign R mod 10, and this remainder is a digit. So print this digit, divide the number. Again take out mod and print the digit and again divide the number. Again take that number, that is 2. So 2 mod 10, 2 mod 10, do it. So you get a digit, then divide it by 10. Then finally it becomes 0, stop. So you have to repeat these 2 steps. How long? Until this number becomes 0. So which loop you will use? Did you get the idea? Yes, we cannot use for loop here because we don't know the number of times that we are going to repeat. 1, 2, 3. Actually, that depends on the number of digits a number is having. If it is having 4 digit, it's a 4 digit number. Suppose you have 9 here, then 4 digit number, this will repeat for 4 times. So we don't know how many digits are there. So we cannot use for loop. We have to use while loop. How long? As long as number is greater than 0. Once it becomes 0, stop. So if you can take the input a number and display all the digits, if you can write the program, so pause the video and try it. Have you done it? Okay, if you can't do it, I'll give you a simple idea. Take the input number from the keyboard, so you know how to do it. sc dot next int. So we have been doing the same thing from all the challenges, almost all the challenges we have done the same thing. Then after taking an input, you have to repeat it as long as n is greater than 0 and stop when n becomes 0. So you have to find out the remainder, mod 10, and you have to change the number by dividing it by 10. And you have to print a digit, a remainder. That's it. I have shown you the skeleton of this one, so at least you can write down a program now. Pause the video, try to write down the program. Okay. If you continue, then I will be showing you directly, I will be showing you the code. I will not be coding it, typing it. Then we have to see other tasks also that are all similar. Okay. We will come to the next one. So pause the video and write the program. Once you are ready, you can solve all these tasks that are similar. Yeah, here is a program for displaying digits of a number from right to left. So this is a regular code taking a number. Then I have one more variable r. Then as long as while, so using while loop, while n is greater than 0, find out remainder and reduce the number by 10 and print the remainder. The remainder that we found here, printing it. Okay. Even without taking variable r directly, you can print it here also and then divide it. Let us run this program and check once. So 237. So we got 7, 3 and 2. So this is displaying digits in reverse. Okay, but we wanted digits, that's all. Remember, this is not a reverse number. 7 is separate, 3 is separate and 2 is separate. So just imagine like this. This is $237 or rupees, but this is 7 rupees or dollar separate, $3 separate and $2 separate. So this is not one single number. It is not one single figure. This is one single figure. Okay. These are 3 different figures and 3 different digits. One more thing, interesting thing I will show you. I will print one more thing here. Okay. I will print n at the last. Let us see. If I give a number, I will give a different number now. 2459, 4-digit number. So I got 9542. Then at last I am printing n, that is nothing but 0. Oh, after the loop n is becoming 0. Yes, definitely, because we wrote that continue the loop as long as n is greater than 0. So at the end, obviously n will become 0. So remember this point. This is helpful later on. So that's it. So hope you have written this program. If not, copy the program. We will move on to the next task. See, the task is simple. Count digits of a number. We don't want to display the digits. We want to count them. We want to count them. So how to count? See, if a number is 2359, then there are 4 digits in a number. How we can do that? How we can know how many digits are there? Just now we saw how to take out the digits one by one. Same thing you have to do. Same thing. You have to divide a number by 10. If you divide the number by 10, then the number becomes 235. Actually, the number is 2359. So if you divide, one digit will be reduced. So then count it. So maintain a counter, count 1. Then again use this number 235 and divide it by 10, so it becomes 23. So count it as 2. Then take this number next step, that is 23. 23 divided by 10, it becomes 2. So now count once again. So after 2, it becomes 3. So we got 3 digits so far. Then take this 2 and 2 divided by 10 will give you 0. So we got 4 digits. As the number became 0, stop. So what is the counter? Counter is 4. So the answer is 4. There are 4 digits. That's it. It's a simple task. So you know how to do this one. We don't want a remainder, right? Remainder we don't want. N is there. Let us say it is 2359. Then which loop you will use for this one? So yes, very good. So you have to use a loop that is n is while n is greater than 0. While loop you have to use. And what you have to do in this every time? Divide the number by 10 and count plus plus. Count plus plus. So this will be counting. So what is count? I should have one variable initialized to 0. That is count. These are the steps. At last, outside this loop, print count. This will give you number of digits. So I have written the program. I have written the complete program. So try it quickly. Try it. I guess you have done this. Simply count, initialize with 0. Okay. Then I don't need a remainder. I don't have to display the digits also, right? Then simply count plus plus. At last, instead of printing this, I have to print count. And that's all. Let us run the program. I'll give the number 2359. So there are 4 digits. I'll run it once again. 54387. There are 5 digits. Yes, it is working. That's it. So the task was simple. Just we have to introduce a counter. Hope you have done this one. Otherwise, you can pause it and write down the code by looking at the screen from here. If you have finished, let us move to the next task. The next task is finding a number is a Armstrong or not. So I will just explain what is it, and you must do this one. You must do this program, right? Because already we have done 2 programs and this is similar to that one with little change. So what you have to do, what does it mean by Armstrong number? If a number is 153, suppose, then take out the digits. So we know very well that the first digit that we get is 3. So 3 cube of a number. Then take out 5 cube of a number. Then 1 cube of a number. Then this is 9 plus this 3 cube is 27. 3 into 3 9, 9 3 is 27 plus 5 into 5 25, 25 into 5 125 plus 1 cube is 1. How much it is? 125 plus 1, 126 plus 27. How much? Yes, 153. If the cubes of the digits of a number, if they are added, and if you are getting a same number again, then it is called as Armstrong number. So I have explained you through an example. Now I will define it once again. If the sum of the cubes of the digits of a number are equal to a number, then it is called as Armstrong number. There are few Armstrong numbers. You can Google it and you can find out what are Armstrong numbers. So how to do this? You know how to take out the digits. We have already seen it while displaying digits. But you don't have to display them. You have to take the cube of a digit. So if you remember, we were getting the result in R assigned n mod 10 that we were doing. Then this R, you have to take the cube and add it. So in the previous challenges, if you have done, I have shown you how to find out the sum. So you can maintain sum as 0. So then you can do what? Sum assigned with sum plus R cube, remainder's cube. See, this first digit is 3. So remainder, you have to take cube. So don't use math.power method. Don't use that method. Write on R into R into R because we want integer results. Right? So if you use math.power, if you know this one and you try to use this, then this will return your double value, and that double value will not be accurate. It may not be precise. So you may miss this one. 1 cube you may get as 0.9999 something. So that will not be added. So you get 152. So you will not get 153. Summation will not be 153. So don't use this. You can try it also, no problem. But this will give you correct answer. R into R into R. So it's not a big thing. See, the number of letters are also less. 1, 2, 3, 4, 5. You have to type more letters for this one. So use this. Then you have to divide a number. So this is sufficient, I guess. At last, you have to print this sum. And you know what to do with these lines. What to do? Yes, you have to put them in a loop. Now, one last important thing. See, if this is done using while loop, right, while n is greater than 0, so what happens when the loop ends? N will become 0. Remember this, n will become 0. Here, n will be 0. Now, what is an Armstrong number? Armstrong number, if the sum of the cubes of the digits of a number are equal to a number. So we got the sum. Yes. If this is 153, number was 153, then sum will be 153. Now you have to check whether this is equal to a number. But how you will check the number has become 0? I have shown you in the previous example that at the end number will become 0. So if you are making number 0, then you should make sure that you are holding that number in some other variable m assign n something, so that you can check that m with sum. This is the reason, right? So this is double equal to, okay. If this is equal, print it is Armstrong number. System.out.println, it's an Armstrong, else not an Armstrong. This is what you have to do at the end. So once again I am telling you, once the loop ends, value of n will become 0. So we should have the copy of this value n somewhere, so we will keep it in m, and sum we will compare with m. M will contain the value of n. Now go ahead and write on the program. You have to at last write on the condition and display Armstrong or not. So if you continue, I will be directly showing you the program. Look at the program here. I am reading a number and I said that we should hold a copy of that number in some other variable m. So do it only after reading. Sometimes students do this in the beginning itself. So how you can do that without knowing the number? First you take the number from the keyboard, then store that n in m also, then take sum and take remainder, all these things you need. Then as long as number is greater than 0, find out the remainder and divide the number. Take the cube of the digit and add it to sum. Keep on adding it to sum. This will be going on. Then at last, when you come out of the loop, you have to do it outside the loop, right? Once you have finished completely, then come out and make sum assign sum equal to m or not. Check it. If it is equal, then say it's an Armstrong number. Otherwise, it's not an Armstrong number. I will run the program and show you. 153. It's an Armstrong number. 151. Not an Armstrong number. There are only few Armstrong numbers are there. You search in Google, okay, and you will find a list of numbers and you can try the next number by yourself, okay. I have given you only one Armstrong number, that is 153. So that's it. So hope you have done this program. So loop, then after that you have conditional statement also. This was the extra work. Now this video will become too lengthy, so next other two tasks you will find them in the next video. So this is in continuation, okay. So this is a continuation of the same challenge. So but it will be divided into two videos to just reduce the size of the video. So watch the next video for reversing a number and checking a number is palindrome or not.